Hey everyone, my name is Omer Noy and I'm a master's student at Tel Aviv University in Israel. I'm going to briefly present our poster entitled The Machine Learning Model for Predicting Deterioration of COVID-19 in Patients, which is about a joint project of a collaborative team from Ron Shomer's lab and 2 medical centers in Israel. So throughout the pandemic, we have been doing comprehensive work trying to provide a decision support to clinicians to potentially improve patient care. And here I will present a specific project in which we utilize machine learning models to detect which patients are at risk for clinical deterioration. So specifically, we developed a model that predicts deterioration in a sliding window approach, such that every hour we make a prediction for the next 7 to 30 hours. To do so, we use the electronic medical records of hospitalized COVID patients from the 2 largest hospitals in Israel, the Sheba Medical Center and the Tel Aviv Sourasky Medical Center. And one was used for model development and the second was used for external validation. So they both contain health data that is routinely captured in the hospital systems as part of clinical care, including both baseline and longitudinal data, such as demographics, lab results, and vital signs. To define deterioration, we used a modified version of a prognostic score called the National Early Warning Score 2, or NEWS2, which is a commonly used clinical risk score that incorporates several physiological variables. And this score was later adjusted for COVID patients by adding the age factor to the formula. So after summing the points across the categories, the aggregated score represents the patient condition at a particular time. So score equals or greater than 7 represents severe condition, and therefore we use the threshold of modified NEWS score greater than 7 as the deterioration outcome, but also different cutoffs can be easily defined. We also confirmed in our data that higher modified NEWS scores were associated with higher mortality and ICU admission rates. So our model development contained several steps, starting from cohort selection according to predefined inclusion and exclusion criteria, time series discretization, which means that we resampled our temporal data to an hourly time grid, feature engineering, in which we tried to capture the temporal behavior of the data, as well as recent data patterns and interactions between variables. Data imputations, where we combined 2 different imputation approaches to impute our missing data. Feature model selection using cross-validation on the training set. And eventually evaluation by using data from a separate hospital. And note that throughout this process, we worked with domain experts and discussed over multiple subjects in order to incorporate clinical standards into model development. So we evaluated the performance of several supervised machine learning models for predicting deterioration, including SVM, linear and logistic regression, random forest, and several algorithms for gradient boost increase. And all of them were tested in cross-validation on the training set. And finally, we chose GradBoost, a gradient boost increase algorithm, as our final model, as it achieved higher performance. So we can see here the results. They show good discrimination, achieving area under the ROC curve of 0.84 and a high value of area under the precision recall curve of 0.74, where all the prediction refer to events at least 7 hours in advance. So the final model achieved also comparable results in external validation on independent cohorts from a different hospital. In addition, we assessed the contribution of each feature to the final model using sharp values. So the top 20 important features are summarized here on the right, including age, arterial oxygen saturation, maximal LDH value, and the standard deviation of body temperature as important features. And this actually emphasized the importance of including summary statistics of medical records for predicting the risk for COVID deterioration. So our model has several strengths. It generates repeatedly updated prediction for each patient during the hospitalization, addressing the temporal dynamics of the disease. All the prediction refer to events at least 7 hours in advance. We showed the importance of including summary statistics of medical markers. The model was tested on an independent patient cohort from a different hospital and demonstrated comparable results. And this project is a part of a more comprehensive work. We are developing models for early warning of additional deterioration outcomes. Also, we're going to extend our design to a multi-center training, and we are already analyzing data from additional hospitals. We also perform a comparative analysis across the different COVID waves, and we implemented several models from previous work in order to perform existing model benchmarking. I would like to thank everyone involved in this project. Thank you for listening.